Alright, this is 5.5, lesson 3, factoring each polynomial by grouping. Alright, factoring by grouping is really one of the fastest ways to do things, but it's often misdone. This is also about half of what we do for the next lesson when we start factoring binomials when the a doesn't equal 1. Anyway, when you factor by polynomial, what you're going to do is, when you're going to have 4 terms and you're going to break it into 2 groups of 2. That's why they call it factoring by grouping. So when I look at the first two, what's common to 21 and 14? In other words, if I broke 21 to be 3 times 7 and 14 to be 2 by 7, they both have 7. So I'm going to factor out 7, and when I look at the x's, I can factor out one of the x's. And then what I'm leaving behind is 3x minus 2. So that's for the first grouping of 2. For the second grouping of 2, what's common to 6 and 4? Now, you're going to say 2, and what I want to push back with is the leading coefficient is negative 6 for my second grouping. So what I really want to factor out is negative 2. And the reason I want to factor out negative 2 is because when I distribute it back in, I need to make sure that I have a negative there. Alright, so if I'm taking out a negative 2 goes into negative 6 3 times. I didn't take out the x. Negative 2 goes into positive 4, negative 2 times. Hey, wait a second. Doesn't this look like the thing we had at the end of lesson 2, where you had a binomial that's the same attached to your terms? So now what I'm going to do is take out the 3x minus 2, and I'm leaving behind my 7x, and leaving behind my minus 2. So now I took my 4 terms and I factored it into 2 binomials being multiplied by each other. Let's do that again, looking at example 2 here. I have 4 terms. With 4 terms, I'm going to factor by grouping. What's common to both of these? 8xy minus 6y. What's common is 2 and y. So I take out 2y and I leave behind 4x minus 3. What's common to 4x and negative 3? Nothing. Their greatest common factor is 1. So I'm actually going to factor out the 1 so I can see what's going on. And if I factor out a 1, I'm not changing anything. In other words, I'm leaving behind the 4x minus 3. Oh look, I have 4x minus 3 and 4x minus 3. So just like before, I'm able to factor that binomial out, leaving behind 2y plus 1. Alright, last one. We're going to do the same thing. How many terms are there? 4. What do you do when there's 4 terms? You factor by grouping. So I look at the first 2 separately from the second 2. In the first 2, I can pop out an x, and I can also pop out a 5, leaving behind 5x, leaving behind negative 3. What can I take out of the second 2? I can take out a y. So plus y, leaving behind 5x minus 3. Oh look, I have 5x minus 3 in both spots, so I can take out the 5x minus 3, leaving behind 5x plus y. Alright, this is factoring by grouping. And we use it a lot, especially on the next sections that we're going to do. It's going to be our go-to thing. And just to point out, it doesn't matter what order you write it in. If I have 2 times 3, that equals 6, but it's the same thing as 3 times 2. That's also 6. So if your terms, so I'm looking at example 2 here, 4x minus 3 times 2y plus 1, it would be the exact same thing if I wrote it in the other order, 2y plus 1 times 4x minus 3.